People don't misbehave randomly. They respond to what the environment is signaling in that moment. The same behavior can work beautifully in one setting and completely fall apart in another, not because the person forgot how to behave, but because the stimulus control changed. When behavior shows up at the wrong time, in the wrong place, or with the wrong people, that's not a motivation problem. And it's usually not a skill problem either. It's a stimulus control problem. This topic gets at the core of why behavior analysts care so much about antecedents. It explains how cues come to control responding, how that control can be too weak, too narrow, or flat out wrong, and why behavior often fails to generalize outside of teaching contexts. If you want behavior to occur reliably in real life, just an instruction, you have to understand stimulus control. Everything that follows is about making behavior predictable, functional, and context appropriate. Stimulus control refers to the way antecedent stimuli come to guide behavior because of a history of differential reinforcement. Reinforcement does more than strengthen behavior, it gives controlling functions to stimuli whose presence or absence coincides with different reinforcement outcomes. When a behavior occurs more often in the presence of a particular stimulus than in its absence, that behavior is said to be under stimulus control. This process is central to understanding how the same behavior can be appropriate in one context and inappropriate in another. Loud talking, arriving late, or using informal language are not inherently problem behaviors. The issue is whether those responses occur in contexts where reinforcement has historically supported them. Stimulus control helps explain why individuals adjust their behavior across social, educational, and therapeutic environments. Applied behavior analysts are especially concerned with problems of stimulus control because many behavior challenges reflect responses occurring at the wrong time, in the wrong place, or under the wrong conditions, rather than deficits in the behavior itself. This chapter focuses on the foundational concept and applied procedures that explain how antecedent stimuli come to control behavior. It addresses stimulus control, stimulus discrimination, and stimulus generalization, and how these processes operate in everyday environments. The chapter also emphasizes applications that are directly relevant to practice, including the use of prompts, fading techniques, and instructional arrangements to teach simple and conditional discriminations. Understanding these processes allow behavior analysts to design interventions that bring behavior under appropriate environmental control. Rather than relying on consequences alone, effective instruction depends on arranging antecedent conditions so that behavior occurs reliably and appropriately. The material also introduces procedures such as errorless learning and time delay, which are designed to minimize errors while transferring control from contrived prompts to naturally occurring stimuli. Together, these topics provide a framework for understanding how stimulus control develops and how it can be systematically taught and refined in applied settings. Control by antecedent stimuli plays a fundamental role in social, educational, treatment, and therapeutic contexts. It helps explain why behaviors that are reinforced and appropriate in one setting may be inappropriate when they occur in another. The same response can produce different consequences depending on the surrounding stimuli, and individuals learn to adjust their behavior accordingly. Loud talking may contact reinforcement on a playground but not in a classroom. Arriving late may be acceptable for a party but not for a job interview. Many behaviors that are labeled as problems are not problematic by nature. Instead, they reflect weak or faulty stimulus control. When behavior is not reliably guided by relevant environmental cues, responses may occur in contexts where they are unlikely to be reinforced or may even produce negative outcomes. For applied behavior analysts, improving stimulus control is often a primary goal. because doing so helps individuals emit appropriate behavior at the right time, in the right place, and under the right conditions. Understanding stimulus control requires examining several core concepts and processes that describe how antecedent events influence behavior. These include stimulus discrimination, stimulus generalization, faulty stimulus control, and conditional stimulus control. Antecedent stimuli can acquire different functions depending on their relation to reinforcement, and these functions determine whether behavior will occur. The chapter also distinguishes between respondent eliciting functions and operant discriminative functions of antecedent stimuli. Although both types of stimuli precede behavior and increase its likelihood, the process through which they acquire control differ. In addition, the chapter addresses how discriminative and motivational functions of antecedent stimuli can be confused if their histories are not carefully analyzed. These basic concepts form the foundation for understanding how behavior comes under environmental control and why that control may sometimes be weak, overly restricted, or misdirected. Mastery of these processes is essential for analyzing behavior accurately and designing effective interventions. Early demonstrations of operant conditioning often focus on simple two-term contingency in which a response is followed by reinforcement. Although useful for illustrating basic principles, this arrangement rarely captures how behavior operates outside the laboratory. In natural environments, reinforcement is usually available only under specific conditions. Adding antecedent stimuli to the contingency creates a three-term relation consisting of a discriminative stimulus, an operant response, and reinforcement. The discriminative stimulus signals whether reinforcement is available for a given response. When reinforcement consistently follows a response in the presence of one stimulus but not its absence, behavior comes under stimulus control. This three-term contingency is considered the basic unit of analysis in operant behavior. It explains how environmental context guides responding and why individuals behave differently across situations. Stimulus control begins when antecedents reliably signal the availability of reinforcement and shape when and where behavior occurs. Stimulus discrimination occurs when behavior happens more often in the presence of one antecedent stimulus than in the presence of another. A discriminative stimulus signals that reinforcement is available for a response, whereas stimulus delta signals that reinforcement is unavailable or less likely. Through a history of differential reinforcement, organisms learn to respond selectively to specific environmental cues. Technically, stimulus control is demonstrated when the rate, latency, duration, or magnitude of a response changes as a function of an antecedent stimulus. A stimulus acquires this control only because responses emitted in its presence have produced more reinforcement than responses emitted in its absence. When the discriminative stimulus signals a rich schedule of reinforcement and the stimulus delta signals extinction or a leaner schedule, responding gradually becomes restricted to the discriminative stimulus. This process results in stimulus discrimination. Importantly, discrimination does not require an absolute contrast between reinforcement and extinction. Differences in quality, amount, or probability of reinforcement are sufficient to establish differential responding and bring behavior under discriminative control. Stimulus generalization refers to the extent to which stimuli other than discriminative stimulus come to evoke the same behavior. When a response has been reinforced in the presence of one stimulus, other stimuli that share similar physical properties may also acquire evocative control. Stimulus generalization and stimulus discrimination are relative concepts rather than opposing processes. Generalization reflects a looser degree of stimulus control, whereas discrimination reflects tighter control over responding. Generalization can be observed when behavior reinforced in one context occurs in the presence of untrained but similar stimuli. With additional differential reinforcement, stimulus control can be sharpened so that responding becomes restricted to a more precise stimulus. Effective instruction often depends on arranging conditions that promote generalization while supporting discrimination. Too little generalization limits flexibility, whereas too much generalization results in responses occurring in contexts where reinforcement is not available or appropriate. A stimulus generalization gradient provides a visual representation of the degree to which stimulus control has developed. It depicts how responding varies across a range of stimuli that differ along one or more dimensions from the original discriminative stimulus. Responses are commonly displayed as rates, total counts, or percentages across trained and untrained stimuli. The slope of the gradient indicates the strength of stimulus control. A relatively flat gradient reflects weak control and broad generalization, whereas a steeper gradient reflects stronger discrimination and tighter control by specific stimulus features. Generalization gradients allow behavior analysts to examine how responding transfers to novel stimuli and how sharply behavior is controlled by relevant dimensions. These gradients are often assessed under extinction conditions to avoid confounding the effects of reinforcement with stimulus generalization. Analysis of gradient patterns helps determine whether instruction should emphasize additional discrimination training or broader exposure to varied exemplars. Faulty stimulus control occurs when behavior comes under the restricted control of irrelevant antecedent stimuli instead of critical features intended to guide responding. This problem is especially common in poorly designed instructional materials that allow correct performance without meaningful engagement with the task. When responses are controlled by factors such as color, position, layout, or superficial cues, students may appear successful while failing to acquire the intended knowledge or skills. Reinforcement delivered under these conditions strengthens behavior that is unrelated to the instructional objective. As a result, learning does not generalize and may collapse when irrelevant cues are removed. Faulty stimulus control undermines instruction by producing accuracy without understanding. Applied behavior analysts should actively identify and eliminate such control by ensuring that correct responding requires attention to relevant stimulus features. Effective instructional design arranges antecedent conditions so that only appropriate stimuli reliably evoke the target responses. In a conditional discrimination, the response that produces reinforcement in the presence of one stimuli depends on the presence or absence of other stimuli. Unlike simple discriminations, reinforcement is contingent on combinations of antecedent events rather than a single stimulus. Most stimulus control in everyday environments reflects these more complex arrangements. Conditional discriminations require sensitivity to contextual cues that determine which stimulus functions as the discriminative stimulus at a given time. In such cases, a simple three-term contingency is insufficient to fully describe behavior. Instead, reflects a four-term relation in which reinforcement depends on the interaction between a conditional stimulus, a discriminative stimulus, the response, and its consequence. Conditional stimulus control allows behavior to be flexible and adaptive, enabling individuals to adjust their responses as environmental contexts change. Mastery of conditional discriminations is essential for accurate responding in complex social, educational, and instructional settings.